1.4 is solving equations using your quadratic formula. With these quadratic equations, you are solving the equations that are in standard form that are something with x squared in them. So a lot of these you'll know how to do already. Like I said, this lesson is pretty much a review of what you have done in the past. With our first example, we are looking at x squared plus 5x is equal to 24, and we are solving this equation by factoring. So I'm just going to rewrite this equation when I bring that 24 over, because I want my equation to be equal to 0. When we're solving any of these equations, we want it equal to 0. So I'm just going to subtract that 24 from each side. And this is going to give me x squared plus 5x minus 24 is equal to 0. Now you want to solve this by factoring. So that c term, that negative 24, you want the factors of that will replace the 5x, or that will give you the 5x when adding. So we're going to take the factors of 24. We have 1 and 24, 2 and 12, 3 and 8, 4 and 6. If these are opposite signs, because when you are multiplying you get a negative, and the addition of them is going to be a positive. If you have a negative 3 plus a positive 8, we get a positive 5. So we're going to use that negative 3 and the 8 to give us x minus 3 times x plus 8 is equal to 0. So what we just did was just factored the x squared plus 5x minus 24. From here, each part of that left side of your equation, you're going to set equal to 0 and solve for the variable in each part. So we have an x minus 3, that's one part, we'll set that equal to 0, as well as an x plus 8, that's another part, we set equal to 0. For the x minus 3 is equal to 0, we add the 3 to both sides, and we get that x is equal to 3. For the x plus 8, we subtract the 8 from each side, and we get that x is equal to negative 8. So we have two solutions here, one that is 3, one that is negative 8. For our next part of this lesson, we are solving these equations by completing the square. If you remember back from Algebra 2, when you complete the square, you are going to move your c term to the other side of your equation, so your binomial is going to be equal to your c term. From there, you want to make sure your a is 1. You're going to do b over 2 squared, and then add that to both sides of your equation. And then complete that by factoring the left side, simplifying the right side, and solving for the variable. So our first one that we have here is this x squared minus 8x plus 13 is equal to 0. So I'm just going to rewrite it here. X squared minus 8x plus 13 is equal to 0. So as of right now, my a, so the coefficient to that x squared is 1. I'm good. My c term, however, is not isolated, so I'm going to move the 13 over by subtracting it from each side. These cancel, so I have I have x squared minus 8x is equal to negative 13. Now, I'm going to take my b term, which is that negative 8, and I'm going to do b over 2 squared. This is going to give me negative 8 over 2 squared, which is negative 4 squared, and that gives me 16. With this 16, I'm going to add it to both sides of my equation that I left off with that x squared minus 8x is equal to negative 13. So I'm just going to add in the 16 to both sides of that. So I'm going to have x squared minus 8x plus 16 is equal to negative 13 plus 16. From here, I'm going to factor my left side, simplify my right side. When I factor my left side, what I have to do is I have to look at that term that was squared. That term that was squared to get me that 16 is going to be what's in parentheses with x. So the only thing I have to do is to take this and add an x in it with the negative 4. And that's going to give me x minus 4 squared, well, that's that trinomial factored, is equal to negative 13 plus 16 is 3. From here, I solve for x. So I'm going to take the square root of both sides. I have x minus 4 is equal to plus or minus the square root of 3. Now, I just move the 4 over by adding it to both sides. And we have x is equal to 4 plus or minus the square root of 13. For the other equation that we have 3x squared minus 12x plus 6 is equal to 0. So 3x squared minus 12x plus 6 minus 12x plus 6 is equal to 0. All right, so for this one, we do not have an a term that's 1, so we are going to factor out that 3. So we have 3 times x squared minus 4x plus 2 is equal to 0. I then want to move that 3 to the other side, so I would divide it by each side. Remember, 0 divided by anything is 0, so those 3's cancel out, and I'm just left with x squared minus 4x plus 2 is equal to 0. I need to isolate my constant first from this step. So I'm going to subtract that 2 from each side. And I'm going to be left with x squared minus 4x is equal to negative 2. From here, I want to do my b over 2 squared and add it to both sides of my equation. So my b in this case is negative 4. So this b over 2 squared is going to be negative 4 over 2 squared, which is negative 2 squared, which simplifies to be 4. I then add that 4 to both sides of my equation, and I get x squared minus 4x plus 4 is equal to negative 2 plus 4. I'm going to factor my left side, add my right side. I get x minus 2 squared is equal to 2. From here, I want to get rid of that binomial squared and just have it be that binomial, so I'm going to take the square root of both sides. We have x minus 2 is equal to the plus or minus square root of 2. I then get x by itself by adding that 2 to both sides, and I'm left with x is equal to 2 plus or minus the square root of 2. So whenever you have any of these equations, you can always use your quadratic formula, which is x is equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a, to simplify and solve these equations. So it does not matter what type of equation you get. If you can solve it by factoring, if you can solve it by completing the square, you can also solve it by using your quadratic formula. Pick out your a, your b, your c. Your a is your coefficient of x squared, your b is your coefficient of x, and your c is your constant. Then plug them in to your quadratic formula. The first example that we're going to do here is this 3x squared. Minus 5x minus 1 is equal to 0. My equation's equal to 0, so what I'm going to do next is to identify my a, which is 3, my b, which is negative 5, and my c, which is negative 1. I'm going to plug these into my quadratic formula. My quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So again, I'm just plugging these values in. We have x is equal to the opposite of negative 5 plus or minus the square root of negative 5 squared minus 4 times a, which is 3, times c, which is negative 1, all over 2 times a. So 2 times 3. The opposite of negative 5 is a positive 5, so x is equal to 5 plus or minus the square root. Negative 5 squared is 25. The negative 4 times 3 is negative 13, times negative 1 is a positive 12, I'm sorry. Negative 4 times 3 is 12 times the negative 1, the positive 12. All right, so 2 times 3 on the bottom is that 6. We're going to simplify what's underneath that radical. So x is equal to 5 plus or minus the square root of 25 plus 12, which gives us 37, all over 6. You cannot simplify this square root of 37, so this would be your final solution. For b, we have 4x squared plus 12x plus 9 is equal to 0. So again, our equation is equal to 0. We can identify our a, our b, and our c. So our a is 4, our b is 12, and our c is 9. Plug this into your quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So x is equal to the opposite of b, so that's a negative times 12, plus or minus the square root of b squared, so that's 12 squared, minus 4 times a, which is 4, times c, which is 9, all over 2 times a, so 2 times 4. The opposite of 12 is negative 12, plus or minus the square root of 12 squared is 144. You have that negative 4 times negative 4, which is negative 16, times 9 is negative 144. And this is all over 2 times 4, which is 8. Your x is equal to negative 12 plus or minus the square root of 144 minus 144, which is the square root of 0, all over 8. The square root of 0 is 0, so x is equal to negative 12 plus or minus 0, all over 8. Negative 12 plus or minus 0 only will give you negative 12. So this x is equal to negative 12 over 8, which simplifies to be negative 3 over 2. For c, we have x squared plus 2x plus 2 is equal to 0. My equation is equal to 0. My a is 1, my b is 2, and my c is 2. So I'm going to plug this into my quadratic formula. I'm going to have x is equal to the opposite of b, which is negative 2, plus or minus the square root of b squared, so 2 squared, minus 4 times a, which is 1, times c, which is 2, all over 2 times a, which is 1. So I'm just going to simplify this. I'm going to have x is equal to negative 2 plus or minus the square root of 4 minus 8 all over 2. So x is equal to negative 2 plus or minus the square root of negative 4 over 2. For the purpose of this section, there is a negative underneath that radical, which means we have no solution. You cannot take the square root of a negative, so when that happens, you get no solution. The last part of your lesson deals with using your discriminant to find the number of real solutions. Your discriminant is just b squared minus 4 times a times c. It's the part that's underneath that radical. If you get an answer by using the b squared minus 4 times a times c, that's greater than 0, you have 2 real solutions. If it's equal to 0, you have 1 real solution. And if it's less than 0, so it's a negative number, then there are no real solutions. If we look at example 4, we are using the discriminant to determine how many real solutions each equation has. So for a, we have x squared minus 4x minus 1 is equal to 0. Just going to rewrite this down here. My equation is equal to 0. So I'm going to identify my a, which is 1, my b is 4, and my c is -1. I'm going to use my discriminant, which is b squared minus 4 times a times c, and see what I get from this. So my b squared is 4 squared minus 4 times a, which is 1, times c, which is -1. I get 16 minus 4 times -1 is a positive 4. So 16 plus 4 is 20. 20 is greater than 0, so we have 2 real solutions. For b, we have 4x squared minus 12x plus 9 is equal to 0. My equation is equal to 0, so I'm going to identify my a, which is 4, my b, which is -12, and my c, which is 9. I'm going to use that discriminant, so b squared minus 4 times a times c. This is going to give us -12 squared minus 4 times 4 times 9. -12 squared is 144. The -4 times 4 is -16. -16 times 9 is -144. 144 minus 144 is 0. 0 is equal to 0, so we have exactly 1 real solution. For c, we have 1/3 x squared minus 2x plus 4 is equal to 0. Again, my equation is equal to 0, so my a is 1/3, my b is -2, and my c is 4. I'm going to use b squared minus 4 times a times c. This is going to give me -2 squared minus 4 times 1/3 times positive 4. The -2 squared is 4. -4 times 1/3 is -4/3 times 4 gives me 4 minus 16/3. That 4 is the same thing as 12/3 minus 16/3. 12 minus 16 is -4/3. That -4/3 is less than 0, so we have no real solutions.